This is the practical session, the three-phase Y connection, experiment 4. In this experiment we will see the behavior of the three-phase circuit on a load. So I will start by connecting this circuit. I have 4, 5, 6 and N in the power supply. 4, 5, 6 and N, which is the variable AC power supply. Variable, that means I can adjust the control knob here and the values here will change. So I will connect 4 and 5 to a voltmeter, 5 and 6 to a voltmeter, and 4 and 6 to a voltmeter. So I'll connect 4 and 5 to a voltmeter. This connection was made. So 4 and 5 is connected to here. 4 and 6 is connecting here. And 5 and 6 is connected here. So 4, 5, 5, 6, 4, 5, 5, 6, and 6, 4. By the way, you can swap. Don't affect anything. So I will start the procedure by turning on the power supply and adjusting the line to neutral voltage. So adjusting this one. How can I adjust this one? You can connect a voltmeter to from 4 to N or 5 to N or 6 to N, or you can just use this control knob. So instead of 4 and 5 or 6 and 5, just move this switch to any one of them, either 4N, 5N, 6N, to measure the line to neutral voltage, not the line to line. So adjusting the line to neutral voltage to 120. So I will turn on the power supply, adjusting the voltage to 120. Now the measurement of the line to line voltage is line to line. So this is line, this is line, this is line, this is neutral. If you take one of them with the neutral, this is line to neutral. If you take two wires from any one of these terminals, this is line to line. So it's 205, 210, 205. So now here you add them together, okay? So we will get 620, then divide by 3 to find the average here. In this procedure, he's asking to reconnect the 3 voltmeters to measure the line to neutral. So the negative terminal is connected to the neutral, all of them. Then from 4 to here, from 5 to here, and from 6 to here. So it will be like this. All the neutrals, all the negative parts are in one terminal, which is the N. So now he's telling me to do the same. I will turn on the power supply, adjusting the voltage, the voltmeter to be 120. 4 and N the same, because he asked me to adjust the line to neutral voltage to 120. So I will get almost 120 in all of them. So add them together, divide by 3, I will get 120. Now he's here. He's asking to calculate the ratio between the line to line voltage and the line to neutral voltage. So you'll bring the line to line voltage to line to neutral, divide by line to neutral, and find the ratio here. Now he's asking here, is the value here is equivalent to this number? So you can answer by yes or no. In this procedure, he is asking to do the same, but instead of 4, 5, 6, you'll be dealing with 1, 2, 3. This is a fixed value, so you cannot affect the value here by changing the control knob. So it will be fixed here, so no need to use the control knob. Just connect and read. After that, we will do the circuit. We'll bring an AC emitter and resistive load and construct the circuit on the station. So I will use 4 and 5 and 6 terminal from the supply, but since the value here is 208, so instead of using this one and adjusting the control knob to the maximum, I will just use this one because the line to line will give me 208. So from 1 to the emitter, AC emitter, 0.5 part. So from 1 to the emitter, 0.5, and from the negative to the upper part of the resistive load. And second is the same, from 2 to the emitter, from the emitter to the load, from 3 to the emitter, and from the minus emitter or the common side of the emitter, the negative part, to the resistor. And the lower part of the resistor will be connected together as a short circuit. Then, instead of using the voltmeter directly, I will just use one and swap the connection. I have connected the voltmeter across R1. Voltmeter across R1 right now. Then I switched the 300 ohms. So the value here of the resistor is 300. Here is 300. And you can switch any resistor to make any combination you want. So switch it on the power supply. The value of the resistor, the supply is 208, and this resistor carry 300 ohm as a resistant value. So the ammeter reading for R1 is, since I am using 0.5 is 0.38. So 0.38. And what is the voltage across R1? Is it 208? Let us check. Since I am using 250, okay, so the voltage right now is almost 90. Then I will continue by taking the voltmeter from here to here and measuring I2 and V2, then I3, V3, then calculating the power. The power equation is IV. So the power consumed by resistor 1 is the current passed through resistor 1 multiply the voltage across resistor 1. The total power will be the algebraic sum of all of them. Thank you.